Hello, viewers, subscribers, and students. Here is BEAM example 17, and I solved this with the limitation of the calculator, that is, it can only solve four simultaneous equations. So I design or I plan the solution to be in such a way that the calculator, which can only solve 4 by 4 or four simultaneous equations, can solve. So there are two parts of the solution. First, let's consider solution 1. Let's consider ABC. So if we consider ABC, then it means AB has no load, so there's no fixed moment, fixed forces. BC, we have fixed moments, but because we consider up to C, then we only compute not the fixed moment, but the moment produced by this overhang, which is 15 times 2 times 1. So for the stiffness of AB, 12 EI over L cubed, so we assume EI equals 1. So 12 EI over L cubed, so 12 over 4 cubed, that's 3 over 16. This is 6 over 6 EI over L square, 6 over 4 square, so 3/8. Then the negative of this cell, then we just copy that. Then this is 6 EI over L square, 4 EI over L, then the negative of that cell, then 1/2 or 2 EI over L, then the negative of row 1, then this is row 2 with 1 and 1/2 interchange position. So remember that. And for students in matrix structural analysis, you can generate this stiffness values per cell. So AB is 1, 2, 3, 4. Then we have BC 3, 4, 5, 6. So this is the stiffness of portion BC. And later on, because we consider CD, we also prepare stiffness of CD. And it is this part, so 5, 6, 7, 8. So take note that we consider first ABC. So there's no fixed forces here or fixed moment on AB. We only consider fixed moments in BC and the fixed force in BC. So this is W 15 6 square over 12. So these fixed moments due to the load would be 45 and 45. Then the fixed force or the reaction here, which is not important at C because it is a support, is just 15 times 6 divided by 2, or 15 times 3, 45 kilonewtons also as shown. Then the moment of this overhang, not treated as fixed moment, but moment of the overhang, because we only consider ABC, is 15 times 2 times 1, so it is 30, and counterclockwise as shown. Therefore, the nodal forces at 2 would be 20, because this is the fixed force, it is 45 downward, so negative 20 and negative 45, negative 65. And for the moment load, it is opposite to 45. This is counterclockwise, so it is clockwise, so negative 45. So we only consider 2, 3, 4, and 6 to solve for the displacements: 2 theta A, 3 delta B, 4 theta B, and 6 theta C. The load at B, 3 is negative 20 and negative 45, negative 65, and clockwise couple negative 45, while the load at C, at 6, 45 minus 30 is 15, and it is counterclockwise. 15 should be counterclockwise, opposite to this couple. So 45 minus 30 is 15 clockwise. That's the net fixed force, so the nodal load should be opposite to that. So counterclockwise 15, and it is positive 15 as shown here. So we are interested only of theta A, which is numbered 2, delta B 3, theta B 4, and theta C 6, U2, U3, U4, U6. So load at A 0 because there's no load in between A and B. Then force 0. Then at 3, negative 65 as explained. Then negative or clockwise couple negative 45. And at C, 45 minus 30. So 15 positive counterclockwise. Then 2, 2. Take note we consider only AB and BC. So 2, 2 is 1. 2, 3 is negative 3 eighths. 2, 4, 2, 4, 1 half. 2, 6, there's none. There's no 2, 6, so 0. Then we copy negative 3 eighths, 1 half, 0 because of symmetrical structural stiffness matrix. Then 3, 3, we have 3 over 16 plus 1 over 18, so 35 over 144. 3, 4, 3, 4, we have negative 3 eighths plus 1 over 6, so negative 5 over 24. 3, 6, 3, 6 is 1, 6. Then copy negative 1, 5 over 24, 1, 6. 4, 4, 4, 4, we have 1 here and 2 thirds. 1 plus 2 thirds is 5 thirds. Then 4, 6, 4, 6 is 1 third. Then we copy 1 third here. Then 6, 6. This is not included because that is CD. We only consider ABC. So 6, 6 is 2 thirds. Therefore, we can now compute U2, U3, U4, U6, which corresponds to theta A, delta B, theta B, and theta C as the inverse, the product of the inverse of this matrix and this 4 by 1 matrix, force matrix here. So with your calculator, you can now solve these values and they are equal to theta A, negative 447 over EI, delta B, negative 1404 over EI, theta B, negative 159 over EI, and theta C, 453 over EI. So that's it. Then we now consider CD to solve for U7 and U8, which corresponds to delta D and theta D. So this is the load, and imagine we have fixed end there. So the fixed end moment is 15, 2 square over 12, and that is 5. Fixed end force is just half of 15 times 2, or it is just 15 times 1, so 15 as shown. So therefore, we only consider CD 5, 6, 7, 8, and we are interested only of the loads at D, which is negative 15. These are fixed forces, so opposite, the nodal forces will be opposite to this. So negative 15 and positive 5 because this is clockwise. So we have F5. We are not interested of the forces because we already found the displacements 5 and 6, 0 for delta C, and theta C is 453 over EI as computed there. Then U7, U8. So the nodal forces, negative 15 opposite to this, and positive 5 opposite to this clockwise moment. And we have to consider the stiffness of these cells only, 7, 5, 7, 5. So that is CD. 7, 5 is negative 1.5. 7, 6 is negative 1.5. 7, 7 is 1.5, and 7, 8 is negative 1.5. Or in short, we just copy this part here of the cell of CD. Then let's expand. Negative 15 equals negative 1.5 times 0 is 0. Negative 1.5 times 453 is negative. So if you transpose this product, negative 1.5 times 453, it is negative 15 plus 1.5 times 453. Likewise, 5 equals 1.5 times 0 is 0. So this is 5 minus 1 times 453. So these are the new force values. So 664.5 is negative 15 plus 1.5 times 453, while negative 448 is 5 equals 1.5 times 0. So 5 equals 1 times 453. So 5 minus 453 is negative 458. Then equals EI times this 2 by 2 matrix here times U7, U8. So U7, U8 can now be computed as the inverse of this 2 by 2 matrix times this 2 by 1 matrix here. So the result can now be computed. U7 corresponds to delta D and U8 theta D. And it is equal to 876 over EI, and for theta D 433 over EI. So that's solution 1. Solution 2 would be to consider ACD. So let's consider ACD. This is another way with the limitation of your calculator. So remember, it can only solve 4 by 4 matrix. So let's consider ACD. So if we consider ACD, then we have to set up the stiffness of AC. And CD, because we consider CD, are the fixed forces. We have to compute the new fixed forces for AC, and this is the load. So let's consider that strip, call that X. So this is 6 minus X. For the concentrated load, the fixed moment at A is negative 20, or 20 times 4 times 6 square over 10 square. That's the formula. And it is counterclockwise. 20 times 4 times 6 square over 10 square. Then for the load plus integral 0 to 6 of 15 dx, formula AX B 4 plus x. The distance of the strip from A is 4 plus x. So PAB square over L square. So P or dP is 15 dx. A is 4 plus x. B is 6 minus x quantity square over L square, 0 to 6. So the value of this is 28.8. The value of this is 59.4. So 28.8 plus 59.4, the fixed force here, the moment is equal to 88.2, adding these two clockwise. On the right side, fixed moment CA. So the load is not important because these are supports A and C. Fixed forces or reactions. So 24 square times 6 square. Sorry, the values are animated first. So that's 121.8. If we add 19.2 and 102.6, but that is fixed moment. We just copy this for fixed forces for CD, 1515. So this is the calculations. Fixed moment CA is 24 square times 6 over 10 square, and that's 19.2. Then plus integral 0 to 6, 15 dx. Then this is 4 plus x square. Sorry for this. Then 6 minus x raised to 1 over 10 square. But you know already how to compute fixed end moments. And it is 102.6. So 19.2 plus 102.6 is 121.8. This one, clockwise. Then the net forces would be opposite to this at A. So clockwise, negative 88.2. Then at C, which is 6, 121.8 minus 5. So the net fixed moment is clockwise. So the load should be counterclockwise. So that's why it's positive 121.8 minus 5 is 116.8. And at this end, we have opposite of 15, negative 15. Then opposite of clockwise, 5 kilonewton meter moment is counterclockwise. So that's why positive 5. Then take note that we consider only ACD. This is the stiffness of AC, 12 EI over 10 cubed. So it is numbered 1256. A is 12, C is 56. And you know already how to prepare this, generate these stiffnesses, and CD. So if we have 2, 2, it is zero point 0.4. There's no 2, 2 in CD here. Then 2, 6, 2, 6.2, 2, 7, there's none, so 0. 2, 8, is, there's none, 0. So we copy 0.2, 0, 0. 6, 6, we have 0.4 here, and 2 here. So 2 plus 0.4, 2.4. 6, 7, 6, 7 is negative 1.5. 6, 8, 6, 8, 1. So 1. Then copy negative 1.5 and 1 here. 7, 7, there's none there. So 7, 7 is 1.5. 7, 8, 7, 8, negative 1.5. Then copy negative 1.5. 8, 8 is 2. So from here, we can now compute these displacements as the inverse of this 4x4 matrix times this force matrix here. And it is equal to, this corresponds to theta A, theta C, delta D, and theta D. So the values are negative 447 over EI, 453 over EI, 876 delta D over EI, 433 over EI, which are correspondingly equal to this. So we make B as the last unknown, delta B and theta B, because this is another solution number 2. So let's consider ABC this time. We already have AB and BC, the stiffnesses. So we only consider 1, 2, 3, 4, 5, 6, and fill in portion 1, 2, 3, 4, 5, 6, and U3, U4. So 1, 2, 3, 4, 5, 6, but we are only interested of these cells here. 1, 2, 3, 4, 5, 6, and at row 3 and row 4, U4. So these forces are not important anymore, because we are only interested of U3 and U4, which corresponds to delta B and theta B. So for 3, 1, for example, 3, 1, negative 3 over 16, 3, 2, 3, 2, negative 3 eighths, 3, 3, we have 3 over 16 plus 1 over 18, so that's why 35 over 144, 3, 4, 3, 4, we have negative 3 eighths and 1 over 6, adding, that's negative 5 over 24, 3, 5, 3, 5, negative 1 over 18, 3, 6 is 1 over 6. So then we have 4, 1, 4, 1, 4, 1, sorry, 3 eighths, 3 eighths, 4, 2, 4, 2 is 1 half, so 1 half, 4, 3, 4, 3, we have negative 3 eighths here, and 1 6, so that's why negative 5 over 24, just like 3, 4. Then 4, 4, we have 1 here and 2 thirds, 1 plus 2 thirds is 5 thirds, 4, 5, 4, 5, negative 1, 6, and lastly 4, 6, 4, 6, 1 third. So negative 65 is changed into, so negative 3 over 16 times 0, it's 0. Negative 3 eighths times 447, it's positive. Then bypass, negative 1 over 18 times 0, then 1 6 times 453. Take note that we know these displacements from the calculations here. So theta A, U2 negative 447 over EI, and uh, theta C or U6 453 over EI. Then delta A0, delta C0. Then unknown delta B and theta B. So negative 65 minus 3/8 of 447, because this is positive transpose of minus 3/8 of 447, then minus 1/6 of 453. So the new force value would be negative 308.125. That negative 308.125 is negative 65 minus quantity 3/8 of 447. Then because negative 1 over 18 times 0 is still 0, then minus 1/6 of 453. You calculate that. Then this 27.5 is negative 45 plus 1/2 of 447, because when you transpose that, it becomes plus. Then minus 1/3 of 453. You will get 27.5. Again, 27.5 is negative 45 plus 1/2 of 447, positive 447, then minus 1/3 of 453. Then we copy this 2 by 2 matrix coefficient of U3, U4. So from here, U3, U4 is the inverse of the product of the inverse of this 2 by 2 matrix and this 2 by 1 matrix here. So the result would be equal to negative 104 over 1404 over EI delta B and theta B negative 159 over EI, just like in the first calculations here. So that's it for this video. I hope that you were able to follow the explanations and the solutions.